So let's say we have this curve here, y equals f of x. And let's say that I want to know the slope of this function at this point right here, at this point that we're going to call a. So how exactly do we find the slope of a curve? Well, we know from algebra how to find it from a straight line. So maybe we can apply the same ideas from that to find the slope of a curve. So we know from algebra that we need 2 points to find the slope. So what I'm going to do is I'm going to look at a point right here. I'm going to call this x. And I'm going to look at another point over here, some distance h away from x. And I'm going to call that x plus h. So the distance from here to here is just h. Well, so first we need to find the value of the function at those points. So at this point x, we're going to have f of x. Then at this point over here at x plus h, it should be somewhere right here. This is going to be f of x plus h. So what's going to be the slope between these points? Well, just eyeballing it, it should look something like this. And that should be our approximation for the slope at a. Well, let's say that I wanted to make a better approximation. So what we can do is just zoom in at a and see if we can get a better approximation. So let me just change the color here. And let's make this point x and this point x plus h. So our slope now is going to look something like this, more or less at least. So, but let's say I want even a better approximation. So as I zoom in even more, you can kind of see that this point is starting to look more and more like a line. So once again, I'm going to pick some x here and an x plus h here, and then this is going to be our approximation for the slope. So we can see that the closer we zoom in, the more and more linear this point becomes. So how do we say that mathematically to find the slope? Well, in algebra, to find the slope, we would say that the slope m is equal to some y2 minus y1 over the change in x. So I'm just going to call that x2 minus x1, or delta y over delta x. Now we can still say that here, but usually in calculus we call the slope of a curve, we'll refer to that either as dy dx or f prime of x. So for now I'm just going to call that f prime of x. So we can say now that f prime of x, our slope at x, is equal to some y2, which we were calling f of x plus h. So f of x plus h minus y1, which we were just calling f of x, over the change in x. So we picked 2 points x that were a distance h away, so then the change of x is just going to be h. And we notice though that the smaller and smaller we made h, that we made the distance between the points away from each other, the more linear our function at that point started to look. And now we know that this equation for slope is based off of the equation for slope for a straight line. So we want to get this, we want to make that function look as linear as possible whenever we're using this equation. So the way we're going to do that is we're going to take the limit of this as h goes to 0. So the limit of all this as h goes to 0. And what we saw up there when we did that is the smaller and smaller we made h, the more linear our function started to look, which means that our approximation became better and better. So Let's try and find out how we can use that, though. So let's look at a couple of examples, just to give a good idea of what's going on. So first, I'm going to say that f of x equals x. And let's say I want to know the slope at the point x equals 0. So how do we do that? Well, what we can do is just plug it into our limit definition. So let's go ahead and write that down again. So we know that the slope of f at x, f prime of x, equals the limit as h goes to 0 of f of x plus h minus f of x over h. So actually the first thing that should be going off in your mind right now is that h in the denominator. So you know that as h goes to 0, at first glance this is going to become something over 0, which we know we can't have. But let's keep chugging along and see if we can simplify this down to a point that we can actually use this. So I said that we want to find the value of f prime of x at 0. So first, let's go ahead and write down what f of x is at 0. So f of 0 we know is 0, and we know that f of 0 plus h is just going to be equal to h. So let's plug that into our equation up there. So we have that f prime of 0 equals the limit as h goes to 0 of f of x plus h, which we found to be just h, minus f of x, so f of 0 was just 0, all over h. So we know that these h's are just going to cancel, and we're going to get that the slope at 0, f prime of 0, is just equal to 1. So it's going to be the limit as h goes to 0 of h over h, which is just 1. And we know that from algebra that the function f of x equals x has a slope of 1 everywhere. So let's take a look at another example. Let's say, I'll go ahead and change my color for this one. Let's say that we have the function f of x equals x squared now. And I want to know the slope at x equals 1. So I want to know the value of f prime of 1. And so let's go ahead and write down what we know. So we know that f of 1 is equal to 1, and we can say that f of 1 plus h is equal to 1 plus h squared. So let's go ahead and plug this into our formula. So we say that f prime of 1 equals the limit as h goes to 0 of f of 1 plus h, which we found is just 1 plus h squared, minus f of 1, which was just 1, all over h. So we can't do anything here as it is, because we have this h in the denominator, and we know from limits that we can't just plug in h equals 0 there, or else we're going to get something that's undefined or indeterminate. So we have to try and simplify this into a different form. So maybe we can start looking at the numerator. So let's go ahead and expand the numerator. So we'll have 1 plus h squared minus 1, and we can simplify that to, well, we can expand that, say that that's equal to 1 plus 2h plus h squared minus 1, and so then our 1's are going to cancel out, and we're going to be left with 2h plus h squared. So let's go ahead and factor an h out of there now, though. So that's equal to h times 2 plus h. Alright, so let's go ahead and plug that back into our formula for our slope. So now we'll have that f prime of 1 equals the limit as h goes to 0 of h times 2 plus h all over h. So now we can cancel this out here, and we'll have that our slope is equal to the limit as h goes to 0 of 2 plus h. So now it's just plugging in 0. So we can make this go to 0, and then our slope at x equals 1, is going to just be 2. So there's actually another word that we usually use to describe this slope in calculus, and we call it the derivative. So we say that f prime of x is the derivative of f of x. And right now it doesn't look like much, but the derivative is actually a very powerful tool in calculus. Usually we use it to describe how something changes with respect to time or with respect to x. But we'll take a look at that in another video. So for now, go ahead and do me a favor and hit like and subscribe, and I hope you have a great day.